Hi, today I will show you how to simulate horizontal centrifugal casting in Polygon software. I start my PoligonSoft and I start mesh generator. Go to geometry, mode and go to file menu, input, step. Now I find my step file with the geometry. Here it is. Select no in this dialog because I have my geometry in millimeters. Do you want to create a partition? Yes, I want. And geometry input completed successfully. And now we see here three solid bodies. Here is a mold. I will rename it mold. And here is a casting. And here is a mold number 2. Now I go to mesh mode, click partition in tree, and click create mesh button here. Go to 2D tab and select algorithm, again 1D 2D, and create new hypothesis, again 2D parameters. And here's input the max and minimum size of finite elements, for example 10 millimeters is a maximum size and 1 millimeter is a minimum size, and fineness is coarse. Okay, and I will create another mesh for casting. Right button mouse click here, create submesh, and select casting here, and see it here in geometry field. Go to 2D tab, and algorithm is again 1D 2D, and the new hypothesis again 2D parameters. Example for maximum size mesh and for minimum size mesh and coarse fineness. Okay, apply and close. And now I will create 2D angle mesh. Right button mouse click and select complete submesh. Successful. Then I see my mesh. I think to remesh it because these elements are too big for this case. Button mouse click, select edit submesh, go to 2D tab and press this button to edit my parameters. And here I want to select maximum size. And close and click here compute, or here complete submesh. Okay. Now it looks good. Now I will compute all other elements. I think it's enough because here is 1, 2, and 3 elements. Okay. And now I will create 3D mesh, but first of all I will check my 2D surface mesh. Press this button, and here see the result 0, 0, and 0. My mesh is fine. Close this dialog and press this button compute 3D mesh to compute the volume mesh. And I need to select this main mesh first of all and press this button, and volume mesh will be computed automatically. Finished. Now, right button was click here and select create groups from geometry and select this tree, all objects, all bodies from partition hidden here. And I see them here and click apply and close. Now I can export my mesh. Button mouse click here and select export mid file. I want to create a folder and save it here. Yes, okay. Now I can close this mesh generator. I can save my study before closing this application. For example, here, I can close this window. And now I start processor of PoligonSoft master. Click open geometry button. It's mesh generator. Units millimeters. Okay. Now I need to find my folder. Here it is. And open this file. I will press no because I will set up new case and I don't want to use previous settings from previous station. Now, so I will press no. Now I see my geometry and I will press volume index mode here, this button. Yes, and I see several colors by volumes. And this volume, this body is a tube, the casting. Double click here and select casting type. And it's number 1. It doesn't matter now. Hi. Yes. Now it's a casting. Here it is. And this volume is mold, and this volume is mold 2. I will make double click here and select mold type. Okay. Now I have one volume here, it's casting, and 2 volumes here, it's a mold. I have a direction all Y axis along my horizontal rotation axis, and this is right. Because in PoligonSoft you can simulate usually only centrifugal casting with vertical rotation axis, and as we want to use other process, we need to position our geometry along vertical axis Y. So for this case, it's a right position. I can use it and I can set up rotation axis along this direction. But now I need to set up materials for casting and mold. Usually we use templates for some casting types. For example, for sand casting, we have template for investment casting and for high pressure die casting, but I don't have a template, special template with some settings for centrifugal casting, and I will prepare it right now. As for alloy properties, I will use some cast iron, for example. So double click here, this button, go to my PoligonSoft database, iron. Let it be this iron. Here's liquidus temperature 1231 degrees and solid temperature 1158 degrees. And now I need to stop mold materials. Double click here, the edit button. I will use new template. And for example, for this region number 2, the volume index number 2, I will use here a steel for my mold. Right button else, click here and load region from base. And here I can select some steel from this base, for example, steel, carbon, and here is a heat capacity and conductivity. For the steel, I will press save button to save it to my folder. And here. And I will call this file CC. That means Centrifugal casting save. Okay. And I see it here. And now heat transfer file. I need to create it and to set up some heat transfer parameters between casting and mold, and between casting and mold and environment, and between mold and environment. So I'll double click here, edit button, and I can select this heat project, and we'll see only the boundaries that I use in this project. I can switch this mode here to boundary. In this mode here, you see that casting has this boundary number 1. You see this color. It's a boundary between casting and mold. And if I will show casting, you will see the same boundary here. And I have this boundary number 17 between casting and environment, and this boundary number 8 between mold and environment. So I have these 3 boundaries. They were set up automatically, and I can set up some heat transfer parameters for these boundaries. For example, as for casting mold boundary, I think 1000 is efficient, but we can use 2000 for example. And as for external boundaries, here is the convection, and I think these settings okay for these boundaries. But maybe as we use iron mold, I can use here emissivity 0.8 as for metal materials, as for casting. These parameters are the same now. And I will press save this and save these settings to my folder right here. For example, CC. We'll call these files as CC. Save. Close. And I see this path here. As for my temperature, I think 1350 is okay. And more temperature, for example, 400 degrees. And now it's enough. I can close it. And what about rotation? I need to stop this rotation axis. Go to Edit Menu and select Rotation. And now, for the mold section here, I can turn this section and go Gray Show Mesh. And if I will click here with the Control button on my keyboard, I will select the center of rotation axis, and here we see the direction of rotation. And if you want to change this direction, you can press here this is rotation axis, and as for rotation speed, we need to set up a value from the technology. I don't know, maybe 400 frames per minute, for example, and press OK. And now I can select more materials and switch on one axis, this axis, and this colors is more materials. If I don't click on this mold building, I see that my steel carbon is here. It's number 2. I will check and press OK. And the color was changed. And I double click here on this particular and select this material and click OK. Now it's okay. I have the wall and the casting. As we use PoligonSoft gravity vector direction against Y axis, but in our case in horizontal centrifugal casting, the right position of the geometry is not like this, but like this. So we can't simulate filling, but we can simulate centrifugation, and we can simulate press, and I will show how to do it. Go to the Start Simulation Parameters window, and in Flow tab, this parameter Enable Flow Model must be switched off. In here on Certification tab, Enable Certification Model is switched off. And here we have calculation time step 1 second, it's okay, and output time step 10 seconds, it's okay too. And simulation stop condition, solid temperature, but we can stop here some other conditions. For example, casting temperature when we stop rotation. For example, can stop here stop temperature condition, and this stop temperature, for example, 400 degrees. That's all here. And on porosity tab, I want to use macro porosity model and micro porosity model, save porosity results, and I need to select alloy properties file, double click here, press this button, go to PoligonSoft database, to iron, and select my iron. Here it is. This is some porosity, some properties, alloy properties for porosity simulation. And that's all here. And in stress tab, I can enable stress model, and calculation time step, I can set up here some large value, because time step for stress model will be selected automatically and it will be changed during simulation. So I can select here, for example, 50 seconds. And now I need to select the alloy stress properties file, double click here, press this button, go to PoligonSoft database, and select here some mechanical properties, for example, for this cast iron. And I can select how to simulate contact between casting and the mold. And the most simple way to do it is to select a rigid mold. If we select it, we don't need mechanical properties, stress properties for mold, and we don't need any additional boundary conditions for mold. A very simple and effective way to simulate stresses in casting without taking into account contact between casting and mold. Now I need to set up output time step, and I think 100 seconds goes varying. Then I can simulate stress in casting not only during certification, during cooling mold, but after mold removal. If I want to do it, I need to check this field, simulate stress after mold and gauging system removal. I feel no gauging here, but I remote, so mold removal temperature will be, for example, 300 degrees or maybe it can be lower than final temperature here. We'll stop thermal temperature simulation when guessing temperature will be lower than 400 degrees, but we can remove more later. And so I can select here temperature, special temperature for this operation, for example, 200 degrees. And that's all. And here I can select some additional results what I need to analyze later. But before one will simulate stresses, deformations, and if I want to simulate some other results, I need to check these boxes. For example, I want to analyze lasting strains, and if I want to simulate hot tearing, I can this here. And as for displacement, we can analyze placement magnitude by default, and if we want to analyze some components or displacement vector, we can select it here. For example, if you want to analyze degree component of displacement vector, it's displacement in this direction, you can select this checkbox and so on. And now we are ready to start. I press simulation button and will create new folder for my simulation and write, save this file here, and simulation starts. So summary, we can simulate filling during horizontal centrifugal casting because in PoligonSoft we have gravity vector along this y-axis, and we can set up rotation axis only along this y-axis too. But if our centrifugal force is much higher than gravity, and in horizontal centrifugal casting it is, centrifugal force is much higher than gravity, we can simulate this type of centrifugal casting, but we need to orient our geometry like here and set up rotation axis like this along y-axis, but we will simulate only solidification. Doesn't matter that our gravity vector is wrong direction. We can see results during the simulation, and as we have first save result, after 10 seconds we can go to the post processor, press this button and start over each one. And here we can see temperature field. Press this button, open temperature file. Here it is. Open. And we see our geometry. This colors temperatures. And we see scale here and time scale. This layer to move along the simulation to the last step, for example. The last step is 10 seconds right now. And here we see temperatures. I can change my background, for example, click here and change it to white and press this big button, it's apply button. And I can change colors of the scale, for example, from this, select from the list, this scale, and press apply button again, and I can switch off wall and see temperature field of casting of tube. I can change the scale here. For example, I can stop the first position. Initial temperature 1350 degrees. I can switch off these checkboxes and select the final temperature. The lower temperature is 400 degrees. Press the right button and see situation. and I can fix this position, yellow color for example, and enter here solder's temperature. Solder's temperature is here, 1158 degrees. Press enter and press apply button. Now can see temperature results. Series apply. We can go in this process. And see how temperature changes in casting. And we can switch on display pipes, and we can see how wall thickness changes due to piping, due to shrinkage. And see can see it here. And we can see porosity field. Press open porosity button and load this file with porosity field. And final step is more interesting. To see the situation, and I have a black color here. So we see porosity area here. And to analyze stress fields and deformations, we need to wait some more time because now it's in progress.